All right. So today is going to be an intro into JavaScript and getting into some of the more intermediate and some advanced features of the language. In the morning, we're going to do a sort of JavaScript overview and journey of all the features of the language. I'm going to demo them and talk about them. But there's a couple things here, like pass by reference versus pass by value and scope that are maybe a little more advanced that we haven't talked about as much. And then after lunch, we are going to see some advanced JavaScript language features that are really newer and part of modern JavaScript. And we're also going to learn a bit about testing and what a unit test is and how to use this JavaScript library called Jest to write tests. And both for Python-based assessments, like the object-oriented programming assessment next Friday, and when you get to the front-end React.js assessment later on, those are weekend projects that include test suites, and you will have to be able to read those tests and understand them in order to write code to pass the tests. So testing is hugely important in software engineering. It's not something that is necessarily exciting or the first thing that comes to people's minds, but it's really key. Let me go ahead and just kind of dive in and start from the top. And do folks have any questions before I move forward? Okay, awesome. So very briefly, I'm going to switch over to the browser and let me just talk about why we care about JavaScript. This is a bit of a simplification, but it's a drawing of how the internet works, how web apps work. And over here, we have browsers. You'll hear this term client and server. A server is just the program that sends something to a client. It serves a client. And a client is just the program that requests something of a server. And this is by far the most common and sort of the most powerful architecture for what's really a distributed system in that, a web app, I've got the website or the web app in my browser, and there's a database and some backend code on a server in the cloud. And each one by themselves doesn't do that much. Really, the system, the application is these two pieces, and they need to work together, and it's distributed because they're in separate parts, right? And what we're all very used to, I think, is whether it's on our phone or our computer, the browser being a client and talking to a server and requesting an HTML page, a website, and the server sending that HTML page over like it is now, and maybe some CSS and JavaScript as well. As we'll learn later with React, we can actually have a lot of JavaScript run in the browser to do very powerful things. And anytime you see really interactive stuff in the browser, like say Google Maps, it's JavaScript running in your browser on your computer. You get some nice little animations these days with CSS. You can like pop-ups and fading and little animations. But to drag around an interactive map, to click on this thing, have all these things come up, to be able to, search here for coffee. Now, when I click on this, the browser is actually going to make a bunch of HTTP requests on the server. And that's all JavaScript code running in my browser, making HTTP requests to a server over the internet. Right? That's JavaScript right there in action, driving the browser and actually generating HTML and CSS. And when people talk about web apps as opposed to websites, or you might hear the term single page app, because we haven't had to refresh the page, that's what we're talking about. And so, like way back in the 90s, there were a lot of different competing technologies to get a programming language into the browser for this level of interactivity. There was something called Flash at one point. There's a language called Java that has absolutely nothing to do with JavaScript. And at one point, they thought Java applets might be it. And then at this browser company, Microsoft, this browser company, Netscape, that went out of business and then became the Mozilla Foundation that created the Firefox browser. This guy named Brendan Eich, in like a week, invented a programming language called JavaScript that has nothing to do with this other language called Java. It was named similarly for marketing reasons because Java was hot, and he kind of got lucky. No one expected JavaScript to become the language of the web and take it over, but it has. And so, lo and behold, whether we like it or not, we're stuck with it. And it does some things really well as a language and other things not so well. And it's changed a ton. And so in your browser, you can go, to view and developer and JavaScript console and type and run JavaScript code in this interactive REPL or read, edit, print loop. Oh, and I can't change a const, which we'll talk about in a minute, but you all get the idea. And this is why JavaScript matters, because if you want to make something like Google Maps, or these days, even Google, if you go to the search engine, this autocomplete dropdown that updates as I type, that's JavaScript code in my browser driving those changes and talking to servers across the internet to do that. For a long time, JavaScript was really only in the browser. And then someone actually decided to take the JavaScript engine that Google created called V8. And when I say JavaScript engine, I mean a program that takes our JavaScript code that we write that's really for humans to read and turns it into assembly language or binary that the computer can then execute. And Python has the same thing. You'll hear people say the JavaScript runtime, the JavaScript engine, the Python interpreter. It's the same thing. It's the program that takes the human readable source code and turns it into ones and zeros that the computer can run. Because code is actually for humans. Computers, they don't need programming languages. They've got binary, but we need the programming language. And so someone took the JavaScript runtime that Google had created an open source called V8, ripped it out, wrapped some code around it so it could interact with an operating system and called it Node.js. And now we've got the same thing here, where I can run JavaScript outside the browser, and you now see JavaScript both on the front end and the back end. And I want to just check in and see if folks have any questions. And I know some of this is review. Let me just see a quick show of hands. How much of this is sort of a review for folks? How much of this is maybe some new information as well? Okay, so a bit of a mix, which is about where we want to be for today. Awesome. So that's kind of the preamble here and why JavaScript is important and kind of unavoidable. If you're doing front-end work, you absolutely need JavaScript. If you're doing back-end work, you might not. And before I dive in and start writing tons of code, and let me go ahead actually and add a comment here. So there's a couple ways to do comments in JavaScript. There's this style where I can do the slashes and the star, and a single line comment looks like this. So before I start writing code, let me ask you all a question. And this is not a trick question, but it is a tricky question. What is a program? No wrong answer here. As I'm saying up front, it is a tricky question. What's a program?
Is a program just like a set of instructions for the computer to run?
Yeah, totally. What else?
I was gonna say like a series of code that accomplishes a certain task.
Yeah, exactly. It's code we write to tell the computer to accomplish a task. What are some different parts of a program? There are some parts that, like every program you will ever write in any programming language, all have in common. Think simple. How about variables?
Variables.
Yeah, exactly. Variables. As I said, not a trick question, but kind of tricky. We've got variables. Um, we've got functions, right? We're probably going to have some sort of loop. There's a lot of other things as well. If we step back a bit, a program is an explicit series of instructions for a computer. It's also human friendly source code. When I run this JavaScript program, and let me hop over here, the computer never sees this. Node, the JavaScript runtime, turns this into binary, essentially. And what we have is source code. And then we have we might call it an interpreter. We might call it a runtime for other languages like Java, C Sharp, C. It's a compiler. And what we end up with is assembly code, which is like almost binary. And then that's what gets executed by the computer. And so the interpreter turns source code into binary, essentially. And then the computer actually runs that. And with some languages, that's actually two separate steps, like Java or other strongly typed languages. And you actually have to run a command to compile your code and then run another command to run your compiled code with what are called dynamic languages, or sometimes you hear them called like high level languages. Um, you'll hear the term just in time compilation. This all happens with one thing. And JavaScript and Python are both like this, right? So the source code is really here for us humans. And that's important to remember because as you write code, the most important thing is actually making it readable for yourself and other programmers. And I just want to pause and see if folks have any questions about this before I move on. And how much of this is review and how much of this is new?
This is all review so far.
Okay, awesome.
Yeah, it's all kind of new for me. I've barely touched Java before.
Awesome. And that's what today is for. So, and trust me, we're going to get into some new stuff for everyone over the course of this morning. So, a program is an explicit series of instructions for a computer. It's also human-friendly source code. And if we think about it, a program really has two parts. It's got data and it's got logic, right? Like when you create a variable and give it a value, that's data. The logic says, take X and add 3, or, to find the area of a circle, take the value of pi 3.14159 and multiply it by the radius squared. The data would be like the radius of the circle I want the area for is 5. And data is actually more important than logic, which takes a while to really start to see. But the more you think about your data, the easier it will be to write programs that are simple, and you'll kind of paint yourself into a corner less. Right? Programs have data and logic. And different programming languages give us different tools, but they all accomplish these same things. And pretty much every programming language out there, you're going to have variables, you're going to have types of variables, you're going to have functions, you're going to have loops. You're also going to have to deal with the problem of names, memory management, and scope. And all these are sort of interrelated. Because as my program gets bigger, I'm going to run out of variable names really quick if every time I name a variable, it has to be unique. So how does my program know, which X I'm referring to? That kind of touches on scope. And as I'll talk about a bit later, we'll see that JavaScript and Python do a lot of memory management for us, and there's some interesting consequences of this. So just kind of file this stuff away. This is a bit more big picture, but as we dive into these language fundamentals and as you start working on these problems today, I want you all to just have this in the back of your mind. Now let's start writing some code and talking about JavaScript. And I'm just kind of scrolling down to the next part of my notes. So, right, we talked about programs having variables. JavaScript, of course, has variables as well. There's a couple different ways to declare them. You can do this. Don't. We'll talk about scope later. This puts a variable in the global scope. This is the old way of doing JS vars, and it's bad. And in fact, if I use prettier, I wonder, yeah. I don't have the right extension set up, but like some extensions that are linters will actually give me a squiggly and a warning and say you shouldn't do this. Similarly, in JavaScript, you can use this keyword var. Don't do this either. What are the two new good ways of creating variables in modern JavaScript? Not a trick question.
Const.
Yep, const, and I heard someone say something else as well.
Let.
Yep, totally. And what's the difference between let and const?
Let is mutable, const is not.
Yeah, and what does mutable mean?
It can be changed, reassigned to without recreating the variable.
Exactly. And this JavaScript command console.log, and I'll talk about what the dot means later, is how we print stuff in JavaScript. And I can go ahead and I can create a variable named a with let, and I give the variable name on the left side of the equality assignment and the value on the right side. I can run my code, and we see that it runs just fine, and it prints out my changed value a. let variables can be mutated or changed. Const variables cannot be mutated, though there's an asterisk to this, which I'll talk about in a bit. Let's watch what happens. And in JavaScript, you used to have to put a semicolon at the end of every line to tell the JavaScript program that this was the end of a line. These days, I'm not so sure it's essential. It's probably a good habit. It's not critical, but you'll see me do it because I just got so used to doing it for years and years and years. Now we have an error. And by the way, let's talk about flow of execution, right? A program is a set of instructions for a computer to execute. The computer executes this code one step after another, what's called imperatively, right? It started all the way up on line 1 of this file. It was all comments, so the JavaScript runtime ignored them. It got to here. It created this variable. It printed it out. It changed the value. It printed it out. It created this variable. It printed it out. It changed the value. It printed it out. Almost not quite, because I got an error. And I can see right here, it tells me what line of code the error happened. And this is the most important part of the error message. Find the line of code that the error occurred on. And in fact, I see right here, it shows me. Error messages, they can be a pain. That said, if you start Googling error messages or use ChatGPT and just put the whole error message in there, you will very quickly find that most errors have good explanations on the internet because 1,000 other programmers have run into the same thing. So I see here the problem, and if I read the explanation, this error message means I tried to change the value of a const variable, and I can't do that in JavaScript, right? And so this is the first and most important habit of debugging, is simply Googling the error message. So I'm not going to do this. I'm just going to print out B. I'll make a note here. So which should I use? Use const. Only use let when you need to. A lot of the times we'll actually create variables whose value never changes. There's some reasons sort of style and approach why const is preferred that we'll talk about later. But this helps you and other programmers see which variables change or mutate and which don't. And actually, the less change you have, the less mutation you have, the better, because that's where stuff gets tricky. And if I decide, you know what, I need B to change, I can just change this to let. So that's declaring variables in JavaScript and the modern way of doing it. And I just want to pause and check in and see if folks have any questions. Okay, cool. Let's talk about data types. And I did something really interesting a moment ago. The type of data or a variable is whether it's a string or a number. And let's go ahead and create some. Num is 5, and you should always name variables lowercase. If I want to have a variable be 2 words, you use what's called camel case, where the first letter of the first word is lowercase and then the first letter of the next word is uppercase. Python, the convention is different, but this is the JavaScript convention. And I'll talk about undefined in a sec. And these are the different types of variables that we can have in JavaScript. There's actually a couple more, but you see them very rarely. You can have a number type, which includes integers and negative numbers and 0 and decimals like 5.3. You can have a string. You can have a Boolean. Boolean refers to this thing called Boolean algebra, but it's short for like true and false. Null is actually a type, and undefined is actually a type. You can create a variable that has a name but no value, and this is actually different than null. And JavaScript also has this nifty type of function. And if I hover over it, I think it's not giving me autocomplete. And let's go ahead and add some of these, and then we'll run these and we'll see what JavaScript says just for fun. And now if I clear the console and I run my code, I'm not printing any of these, which is a bit of an issue.
You have to
Because-
console log them.
Yeah, exactly. I forgot to console log these. So there's two ways I can do this. Type of is actually a function. I could say, let's have this return its value and assign it to this variable on the left side of the equal side and console log that. And that'll work just fine. And now I get down here, number, right? This function returned a value. It got assigned to this variable and we print it out. I don't want to create all these one-off variables. I know that this function is going to return a value. You can think of it as like spitting something out to its left over here. And I can actually type this other function, console log, and the argument I pass in will just be whatever value gets returned here. And so when the JavaScript engine goes line by line through the code, and it gets here, it uses the parentheses to figure out the order of operations, similar to the order of operations in math, where it says, oh, I print something. What do I print? I actually have to run this type of function to figure out what I print. Let me see what I have to pass in as an argument here. I have to pass in this string here as an argument. I can execute type of. I can return that value. In here, we will then end up with string, because it's type string, and string will get console logged. And it's really important to practice sort of mentally modeling what the computer does and being able to sort of simulate being a computer and executing your code line by line, because that's how you understand code and debug code. And I just want to check in and see if folks have any questions about what we're doing here on line 73, because this is a good time to kind of go over that a bit. Cool. So we can do that here as well. For the Boolean, we can do it here as well for null. And finally, we can do it here for undefined. And now if I run my code, then I get these messages, which is great. But, what if I get the variable names wrong? It'd be nice if maybe I could add a message. If I use the backtick and I kind of put a backtick here and here, and I put this, I have to use like $, curly bracket, close bracket, but I can say my string var type is, and now if I don't have a typo, I get a much more useful message. And I'll get rid of the empty space here. And this is what's called string interpolation, where we can put a variable inside a string. And we use the backtick, and then the variable we put inside, and whatever is inside the backticks is the string, and whatever variables we want. And I could do this as many times as I want. I use the $, and the curly bracket. The last thing I want to point out with variables is something we saw earlier, where I was able to change the value of something. And this code works just fine, right? If I run this, this will work, and this probably doesn't even look surprising. In other programming languages called strongly typed languages, this would throw an error because the programming language is not designed to allow you to change the type of variable. You would have to like declare something like this, and once you do this, Q has to stay a number until the end of time. JavaScript and Python are what are called weakly typed languages, or a dynamic language. Dynamic as in able to constantly change the types of variables. Usually compiled languages like C and Java are strongly typed. And there's trade-offs to each approach. And I just want to check in to see if folks have any questions or are curious about stuff before we keep on rolling. Okay, awesome. So we've seen the variable types, we've seen strings. Just one good thing to know about strings is, let's say I want to get the first letter of a string. We can use bracket notation to access individual characters of a string. So I can print out the third character in message is my string, and then the square brackets. And that works great. Let me change this.
Is that the same as like indexing in Python?
Exactly. And in fact, I kind of made a mistake here on purpose that I realized I need to change the message to, because what's the issue if how does with indexing like
Starts at 0.
Yeah, exactly. I wasn't sure how to ask the question. We're 0 indexed, just like with Python. Most things in most programming languages are 0 indexed when you have to kind of do indexing. So that's a useful default. So now we get the third character. We'll talk about JavaScript arrays in a bit. Under the hood, a string is actually an array, which is pretty similar to a Python list, and that's why we can do this. There's a lot of JavaScript functions for working with strings, messing with strings, and indeed for all these different types of numbers. We have a big JavaScript standard library that we don't have to import stuff for. VS Code autocomplete is great in this regard. You'll also just want to look stuff up. And also for JavaScript, the site, the Mozilla Developer Network, is kind of the canonical gold standard for JavaScript, CSS, and HTML documentation. I know there's sites like W3 Schools, but if it's JavaScript, HTML, or CSS, start going here. This is where the whole programming world goes. You'll find the explanations are a lot better, and very soon you'll be going beyond kind of what W3 Schools can give you. Geeks for Geeks is actually pretty good, but this is the canonical resource, and you can actually type code here. I can actually modify this and run it, which is great. And what this does is it raises 7 to the second power, or it squares it, right? And 7 squared is 49, which is great because I had forgotten I have to add the 2 as the second argument to this function. And let's go ahead and just print this out. Right. And so JavaScript does have like a rich standard library of tools that you can use for all sorts of things. And it's worth sort of, as you work on stuff, digging and researching that stuff. And you'll see some of the coding assignments will introduce you to those things as well. A good one to know actually is floor, which will round a variable down. Right. And we're not going up or down to the closest. It just rounds it down. So that's a good one to know as well. So we've got strings, we've got numbers, we've got Booleans, true and false there's a couple things I want to mention about true and false. I think I'll come back to them in a second. Let me talk about null and undefined, and then we'll come back to Booleans. Null is a really important concept in JavaScript. Null is a value. It is explicitly nothing. And here's why this matters. If we're writing a program and we're working on a program and we're looking at this data, what's the difference between number of students null and number of students equals 0?
Null doesn't exist. 0 is an actual integer.
And what does that tell us in the real world about our student management software, about the number of students in the class for each of these scenarios? And this is a bit of an open-ended question. So Chase, I think you're muted.
Is it just that like the number of students with the integer 0 means like when you I don't know how to put it into words, but like when you like try to return it, it's going to show 0 versus like showing null or empty. I don't know if that makes sense or if it's right.
Yeah. And in fact, let's go ahead and let's change this variable name. And let's say this is like a workout tracker. I worked out 0 times this week. If we're writing a program, programs ultimately, we get to like play God and create a universe and model a universe and decide what's in it. And in the universe of the workout tracker, 0 workouts is a valid value. I worked out 0 times this week. This is legitimate, valid data. Null does not mean 0. It means this has no value, which probably means maybe this is a future week I haven't gotten to yet. Maybe we have to do something else in the program, or maybe there could be an error, right? Normally you see null as a placeholder. Like if I'm writing a program and I just kind of need to create this variable first for some reason, I can give it a value of null so that the program, knows it exists. But, I don't want to use 0 as a placeholder because 0 is a real value, right? That gives us meaningful data. So that's a little tricky, but that's the thing to remember. And you should never use 0. I mean, sometimes you'll use the empty string as a placeholder, but you should kind of try to avoid it. 0 you should never use as a placeholder. That's what null is for. Undefined is not null. It's no value at all. And if I print out the type of this is not null, we'll get undefined all the way down here. And let me quickly comment out my previous console logs just so we don't get too cluttered. Give me just one moment here, folks. Here's the thing. Here's some variable name that I never made. I never said let this does not exist. When we print out the type of it, we also get undefined, right? So often if you see undefined, it might mean there's an error. Maybe there's a bad variable name. Something has gone wrong. Null is usually a value we explicitly set somewhere. Now, why does this matter? In JavaScript, I can write if and else statements like this. And let me do a little bit more. I just want to get rid of these console logs. Bear with me 1 sec here, folks. That ought to do it. Thank you.
Could you back up just a second? How did you do that?
Oh, so yeah, I've been using this text editor called Vim for ages. That's a command line editor. If you notice right now, the cursor is a block. If I hit the key I, it takes me into insert mode where I can type. If I hit escape, it takes me into command mode. And if I hit the letter D twice on my keyboard, it deletes the line. But and VS Code has a really good Vim mode, actually, for anyone that's interested. There's these two like sort of text-based editors that both came out in the 70s, Vim and Emacs. And it's kind of the classic programmer argument, which one they prefer, because they're totally different. They're both amazing. They're both open source. They're both incredibly powerful. They're also both pretty darn complicated. You'll see Vim on the command line. Like if I type Vim example.js, it'll be here. I think Git commit messages would use Vim by default. And now to quit this program, I have to type colon and Q and hit enter. And that's why I kind of just frankly avoid Vim, like when we're teaching this stuff. If anyone's interested, just install the Vim extension for VS Code and you can turn it on and off. And I'd be happy to chat more about it later.
All right.
Yeah, but it lets me do all sorts of nice things like select a string and go through all the instances of it. But you could do the same thing in VS Code with find. And I could, if I expand this, I could replace, actually what's useful to know for VS Code is Control/ or Command/ on Mac will toggle commenting out a line. That's actually really, really useful. So kind of circling back to this. This is pretty straightforward, right? I think this is the syntax for an if statement. You can think of if as like a tiny function, and it takes whatever's in here and evaluates the truthiness value of it. And if it evaluates to true, it will execute whatever is inside these curly brackets. If that thing is not true, and we add an else statement, it will go to the else statement. All right, and so here we go to the else because the value in here is false. JavaScript is very liberal about true and false. It's so liberal that JavaScript programmers have come up with these terms, truthy and falsy. A string is true. A number is true. Null is false. And this is important because you will use this a lot in JavaScript. Null is false. Undefined, right? This is an undefined variable, is false. Just to make things worse, 0 is false, which is terrible, by the way. In Python has truthiness, and I think 0 is true, because don't get it twisted. True and false are separate things. In our workout tracker, 0 workouts this week is not false, right? That's a valid value. So this was, someone thought they were being smart, and to be fair, they made the JavaScript language in like 2 weeks, but this has haunted JavaScript programmers since the beginning of time because it is the source of 1,000 difficult to track down errors. An empty string, a string that has nothing in it, is also falsy. A string that has an empty space, I actually don't remember. An empty space is truthy, which is fine. That's how it should be. An empty string, maybe that should be false. I don't know. Negative numbers, I don't remember if these are true or false. True, right? So truthiness and falsiness are tricky in JavaScript. Truthy, true, any number not 0, any string, as long as it's not an empty string. Falsy, false. 0, empty string. Null, undefined. So these are some of the terrible gotchas of JavaScript. And a lot of JavaScript programming patterns have been created to avoid these problems. Let me talk about another JavaScript behavior just with Boolean logic in general. And it's using the OR statement. So let me ask a quick question. So there's this idea in logic or Boolean logic, there's really kind of 2 statements, and or. And you can make these things called true tables, and they look like this. Well, and that's really it. Those are the only 2 combinations. True and true evaluates the true. Any guess what true and false evaluates to?
False.
Yeah, exactly. Not a trick question. And I know that this is review for some folks, and it might be new for others. False and true, what do we think?
False.
Yeah, and false is false. True or true? True. True or false? What do we think about this one?
True.
Yeah, either of these can be true. And false or false is false. And in JS, in JavaScript, and looks like this, and or looks like this. So if I do this, we should get false unless I've made a typo or totally lost my mind. And let me just comment out these console logs. Right? True and false is false. The order doesn't really matter for and. We're going to see that order matters a bit for or. And where this really starts to matter is, let's just say, you know, is hungry equals false. Let is dinner time equal false. And actually, let's make is hungry equal true. And my program is going to be, if it's dinner time and I'm hungry, let's eat. Right? So I might be hungry, but it's not dinner time yet. Else, if I'm hungry and maybe let's have lunchtime, let's have breakfast time, and maybe, if in lunchtime and I'm hungry, I can eat lunch. And if it's breakfast time and I'm hungry, I can eat lunch. And finally, if it's none of those times, but I'm hungry, we can have a snack. Let me scroll up a bit so we can see all these lines of code in one, and then go ahead and run this. So right now, I can have a snack, but it's not breakfast, lunch, or dinner. Now, if it's dinner time, now we eat dinner, right? And so this is where you'll see conditional logic is what it's called, because these are the conditions for an if or an else statement to evaluate to true. Maybe for lunch, I want to be generous, and if it's lunch or I'm hungry, we eat. And for lunch, if I'm even if I'm hungry and it's not lunchtime, we'll still eat lunch. Oh, and I need to change dinner time back to false so we can trigger our lunchtime. Right? So lunchtime is false, but I'm hungry, and this is an or statement, so we eat. So This is conditional logic in JavaScript. You'll also see the or statement used for something called short circuiting to create sort of default values. And then we'll take a break because I realize we've been running for an hour. Let's say I want to make a variable. And let's say I want it to be like my favorite food. But if I don't have a favorite food, I'm going to give a default favorite food. In JavaScript, when you create a variable whose value never is going to change, you can do it in all caps. And we'll learn a bit later why, even with the const, this matters. So there's nothing magical about the all caps. It's just a convention. And let's say I have a variable, user input, or even better, let's write a function. We haven't talked about functions, but I think everyone has a degree of familiarity. And we'll make it look like this. And we'll put this inside here. And what I'll do is I'll return food or default favorite food. And so my favorite food is going to be sushi. Barbara's favorite food. There's no argument in here, which means this variable that gets created inside this function is, I believe it's either undefined or null, which will give it a falsy value. And so the or statement will just keep on going and return the other side of the or statement. And we see here Barbara's favorite food is the pizza by default. And to show that, again, if I'll write up here, sushi or pizza. And line 54 right here will print out sushi. And in fact, let's just make this, let's add a little message here so we can see this more easy. And this term short circuit, I'm pretty sure it came from electrical engineering. And if I change this to an empty string, which has a falsy value, we should see pizza. Right? Or if I change this to null, we'll see pizza. And so this technique is called short circuiting, and it's a nice way to use the or statement and conditional logic to set default values for stuff. This is definitely a good time for a break because I've been going on for a minute. We've covered a lot of good ground here. Do folks have any questions before we take a break? Okay, how are we feeling? I know some of this is review, some of this is new, and it's a mix. I also know it's been a lot of zooming, like on a scale of 1 to 10, how are we doing? Are our brains mush or are we doing okay? 5?
7.3.
Okay, awesome. So we've covered some good ground. We've gotten about this far. But we've hit a lot of good stuff. After the break, I'll talk about arrays and objects. We'll talk about Well, actually, we'll talk about pass by reference and pass by value and arrays and objects. And then we'll talk more about functions and scope, and a couple particular things like the ternary operator and loops. And then we'll either get in some work time or we might just dive into the advanced JavaScript stuff before lunch. Sound good?
Can I ask one thing real quick about that last example?
Absolutely.
Okay, so I see in line 175 you don't throw any value in. I thought normal cases that would, that would error. I understand that's false, and that's why,
Mhm.
default favorite food gets returned as, pizza by default. But I guess I just never seen that. I would think I
Yeah,
thought you'd have to throw a default value in. Otherwise it would error, give you an error message.
great question. In JavaScript, it does not throw an error. In Python, it might. Can anyone remind me? Does that error
I
I think
or
think it
not?
does.
Python does require a thing.
Yeah. And in fact, we can test this out real quick. If we just quit the node REPL, let's open up the Python REPL and let's make a function def hello message print message, and that should be it. Return. I'm totally failing here in typing this out in the REPL. That ought to do it. Let's try that. So you guys are correct. I thought so as well. And that's an excellent question. I'm so used to this that I missed this point. And this is a pretty big language difference. Python by design is explicit. If a function has an argument, you got to pass an argument unless you give it a default value, which we'll learn how to do tomorrow. JavaScript does not work that way. You can have all the arguments you want here. Vacation. And you don't have to pass any of them, which a lot of people hate, though it makes the language very flexible. And that JavaScript code will still run just fine. I'll talk a bit more like exactly what's going on here when we get to functions later, but you raise a very good point. JavaScript functions, if you don't pass a value for an argument, it will just insert null or undefined. Like if we console log, let's console log all these things. And then we will break. And these are all going to be undefined or null for Barbara, right? So now I have this console log statement. Over here on line 74, we should see sushi printed out. Both of these are going to be null or undefined. When I run the function again with no arguments, all of these are going to be null or undefined. And indeed, it's undefined. And this is a great example of undefined, actually, right? Because we need this variable name to exist so that our function can do stuff with it. But the way JavaScript is designed, they decided we're not going to throw an error if it doesn't have a value. We're going to give it the value of undefined, right? And in fact, that's a good example of the difference between undefined and null, because like null might be like, what if I don't want to have a favorite food? And what if we don't want to require users to have a favorite food? Then null might be a perfectly valid value. And that's how our program knows this user doesn't have a favorite food. Or like this is upcoming vacation, right? This is me saying I love sushi and I don't have any upcoming vacations. And null is serving a meaningful purpose. Here, with it being undefined, it's giving us a different message, just that we don't have any information on this at all. Does that make sense? And this with this example of null. Yeah, great question, because this is actually a perfect example of where null is valuable, right? Because this, no vacation, that's not a good way to represent that data in our program. That's not a good way to model our universe. 0, no upcoming vacation. That's a bad way to model our universe. This is a good way in the universe that we create for our program to model that the user Adam has no upcoming vacations. All right. On that note, let's take a break. Let me pause the recording. All right. So we covered a lot of ground. We learned about the basic data types and variables in JavaScript. And we did a pretty deep dive into that. And we also learned about conditional logic, right? And we saw some examples in action. And we saw this short-circuiting technique. And we also got a little bit of a preview with functions and learned this really important distinction between JavaScript and Python, where in Python, if a function takes in, 3 arguments, you've got to pass it 3 arguments, or the Python will throw an error, because that's how the language is designed. JavaScript is a lot more liberal, and function arguments aren't required. JavaScript will just set them to undefined if no values are passed when the function is called, right? And when I say the function is called, if, we're simulating being the computer in the JavaScript engine and we're going through our code line by line by line by line, when I get to 169 for the first time, JavaScript isn't executing this code, it's reading it in. And it doesn't execute it until we call this function. And here on line 176, JavaScript says, okay, I got to go find a function named getFavoriteFood. Let me look it up, and I got to pass these arguments in. So let me ask you all a question. In these 4 lines of code, from line 169 to line 179, how many times does this variable default favorite food get created?
Is it just once?
Yeah, get created just once.
Well, maybe. If I run this code, and let me go ahead and just comment out some of these other console logs. My
We call it
apologies.
twice. So shouldn't it get created twice?
I think it'll get created twice. Now, under the hood, there might be some cleverness going on, but in essence, it gets created twice. Because let's run this code. How many times does this console log statement on line 170 get executed? Not a trick question, because it's right here in the console logs. We've got it once here and once here. Twice, right? Because we call our function or execute it here on line 177. And when we call the function, JavaScript will run all the code inside of it. When we call it again, it runs all the code inside of it. So every single time I run this function, it creates a variable. Right?
In Python, you can reference a variable by its memory ID. Can you do that anywhere in JavaScript to see if it's actually creating it once or twice?
You can. It's not. How do we do that? I'm not sure it's really necessary, to be honest. Because And to be honest, it might be creating it once because JavaScript is being smart and reading this in. But the main point here is still that all the code inside this function block gets executed every time the function is called. Like if I said, let foo equal food and vacay and last name in these lines of code, how many times does this variable foo get created?
Twice.
Yeah, exactly. So without worrying about the JavaScript engine being clever and recognizing that this is a constant, just sort of looking at it at a simpler level, why would this one be any different, right? You may be right that there's some sort of optimization going on here, but that's a little outside of scope. And even if there is, what we could do, and I'll talk later about why this works, is we could define this variable outside the function and use it inside of it. And now it clearly only gets defined once, right? And instead of a variable, think about if we create another function in here. In these lines of code, how many times are we creating this function that's inside this other function?
Wouldn't still be twice.
Yeah, exactly. And I see the 2 up there as well, Jack. Right? And so the function might be a bit of a better example and a more intuitive one, where as I'm designing my programs and they get more complex, this is fine to get it working, but I probably want to refactor this and pull it outside. And I can define it here, where it's defined once, and I can use it inside here. If I really wanted to, I could pass the function and I could pass this in as an argument, but that's a little out of scope. But I just wanted to point this out to help illustrate the difference between a function definition and function execution. And as you all write and read code, that's a really valuable thing to be aware of and to be able to kind of walk through. And I just want to check in and see if folks have any questions before we move on. Okay, awesome. Let's talk about complex variable types. The variables we've seen thus far, strings, booleans, they're called primitive variables because like they're foundational. Like a boolean isn't made up of anything else. It's just a boolean. But in JavaScript, there's a more complex variable or data type called an array. And it looks very similar to a Python list. And as you can see, this array is made up of other things. And in fact, I don't have to put all strings in it. I could put 0 and true or whatever I want, other variables. But for the purposes of demonstration, I'm just going to put days of the week in here. And so this is not a primitive variable type because it's composed of other variables. And I can use bracket notation and zero indexing like we were talking about to access the items or elements in this array. And the important thing about an array is this. An array is ordered. JavaScript guarantees to keep these things in the array in the order we put them. It's an ordered list of values. And you'll hear each thing in an array is called an item. You'll hear it called an element. So you might hear like, loop through all the elements in the array or the items in the array. And it's extremely flexible. Right, and I can go ahead and I can print out and it looks like I have a typo somewhere. Day is not defined. That would be because I got really lazy. And let's just make this a really short variable name to keep life simple. I will call that days. A reference there, by the way, means a variable is a reference to a value, and it couldn't find the value that this thing was referring to because it didn't exist because I made a typo. And now we get our days of the week. And let me just quickly comment out these other console logs. Okay, thank you for bearing with me there. So, and this is very similar to Python lists. Arrays are super useful. I can add to the end of an array by pushing. And now that is going to be the 5th day of the week. Which I believe is going to be like, I always have to take a moment with the 0 indexing to make sure I get it right. And let's see, why is it not printing? It's because I didn't save. If you look at the top here, examples.js, when it's a white circle like that, it means the file isn't saved. I do recommend turning on the autosave. It's probably the easiest and simplest way. And now I've added something to the days of the week. I can remove something from the end of an array by using pop.
What did push do?
Yeah, push adds it to the end of the array.
So it just takes it from where it's at and instantly puts it at the end.
Yeah, exactly.
Okay. Gotcha.
Yeah, we'll talk about this other data structure called a stack later. That's where these terms push and pop come from. And if you imagine a stack of pancakes, you can only put a pancake on the top of the stack, and that's push. And you can only take a pancake off of the top of the stack of pancakes, and that's pop. And JavaScript arrays do some extra stuff, including push and pop. And so if I do days pop, a couple of things happen. It will return the thing we pop. And if we look at the array, it's been modified. And we'll see that that last day has been added and removed. And so we see here, if you guys can see where I'm highlighting down in the console where the pop happened, we can see here where, or I'm sorry, this is where the push happened. Excuse me. We can see here pop is actually a function. It does two things. It removes the last element from the array, and it returns it. And so we can get rid of something at the end of our list, and the array itself is modified. There's a lot of other nifty and useful things you can do with arrays. A quick perusal through the MDN docs on arrays is probably worth it, but you will also get plenty of practice just doing this in assignments, because arrays and objects that we're about to learn about are bread and butter. And this length here is probably also a very good one to mention, because that's super useful. You can see here, some of these are more complex. Some of these are simpler. I would like take 10 minutes and just read through this, because you'll see like all of these are actually extremely useful. We're not going to go through each of these in detail, but in the coding assignments, you will have to use many, if not all of these array functions over the course of like the next 15 weeks. And there's a lot we won't use as well.
What if you
Yeah.
because an array, I guess, is like the list or whatever. So what if you push or pop something that's not an array?
You mean like if I have like
A different data type, I guess. Like you can't. I don't know. Could
Like a string, maybe?
yeah.
yeah. So let's try this out with two different things. Let's try it out with a number. First of all, I'm sorry, let me make this age. We're going to get an error. We're going to talk about the dot notation in a moment, because this has to do with JavaScript objects. But most variables in JavaScript, if they're not Booleans or null or undefined, are actually sort of objects under the hood and have some properties, including functions or methods that we can call. And so most of the time you'll just get an error because this method doesn't exist. The same way where, if I'm trying to open a door that has a keypad and I have a physical key, I'm looking, where I put the key in the lock. That's just not how that door is designed. Right. And so this just doesn't exist. Strings are a little different in JavaScript.
My name.
Oh yeah, thank you. Thank you. I'm actually not sure if this will succeed or fail. And it fails. So strings are an interesting case because you absolutely can do my name bracket notation too, right? And this is really similar to how we work with arrays. And it makes, there's something array-like that this string is stored as. Because if I scroll up here, we see that letter I, but we can see that a string is not an array and it doesn't have this pop method. And if we try that, that's probably going to fail as well. And the place to go, again, that's the best place to kind of answer these questions is the MDN site. Also just testing it out. But if we look up the docs on the string, strings do have actually various methods attached to them. We can use this character at method, and you can see the whole list over here. Concat to combine them, includes to see if something is in a string. We can add padding. We can slice a string to get a substring. So strings are a little more complex than they appear. Numbers, I'm not sure about if numbers might truly be primitive. No, but even here, yeah, because we'll talk about it in a minute, but sort of under the hood, everything is an object in JavaScript and has certain properties. But I also don't want to get too lost in this because I think this can get a little confusing. But like number dot is integer. So if I'm understanding this right, if I go to the JavaScript REPL, I should be able to do 125.7 dot is integer, or maybe it's yeah, it's a little confusing because there's also a JavaScript. I hate to use the word class in JavaScript, but class called number, and there's a class called string. Really, they're objects. So it's a little out of scope of what we're going to look at now. But the short answer is pop and push are specifically for arrays. Let me talk about objects because that will actually help a lot of this make more sense. Objects are the bread and butter of JavaScript. Arrays are great for putting stuff in order. Objects are great for looking stuff up. Like maybe we want to have let's just make this a person named Alice. An object is a curly bracket, open and close. Objects are like sort of like Python dictionaries with keys and values. The key is the thing to the left of the colon, and you don't have to put a string around it. You can separate object properties with commas. The value is the thing to the right of the colon. And, the value can be anything. Often you will see objects written like this. And it doesn't matter that we put this on different lines. JavaScript doesn't care. You do need the comma at the end. Otherwise, you will get an error. And often you'll see what's called a trailing comma at the end, because what's really easy is, oh, I want to add something new. And I forget the comma. And if I run my code now, I'll get an error. Syntax error, unexpected identifier, hometown, line 227. This is probably one of the most common mistakes to make. The issue is the missing comma. If you hover, it will give you the hint, but you kind of have to know it. And so a good habit is just whenever you have like a list of stuff like this in JavaScript, just add a comma at the end of the last one so you don't, it avoids ever having that error to begin with. Right? So these are objects. This is how I can create them. Let's go ahead and print them out. And let me do a little commenting out of console logs just so we don't have all this other noise. So just bear with me for a moment. Okay, awesome. Alice, Bob. And that is an error. Alice, Bob. How do I work with objects? This is dot notation. I can have an object, I type dot, I get really useful autocomplete actually from VS Code. And these are, we call them properties. And I wanted to put a plus here. And by the way, in JavaScript, you can combine or what's called concatenate strings with the plus symbol like this. So this will form a new string. Alice's name is, and whatever this is will get turned into a string. This is super friendly and super useful. By the way, console is an object. And this is a property on the console object that just happens to be a function. We will talk a bit more about this later, but that's what we've been doing this whole time. If I do type of console, the type of the console is an object. If I do type of our days of the week array that we made earlier, that's an object too, right? If I, let's see, can I scroll far up enough to see it all on one line? It's a little hard to see. I'll just, let's do this instead. Instead of days, let's do months equals January, February, March. And I want to point this out because this intuitively should be supremely weird. Why is the type of months an object when we know it's an array?
Because everything's an object.
Yeah. Everything in JavaScript is an object except for some of our primitive variables like string and number, and string is really an object, and null and undefined and true and false. JavaScript sort of hides it, but everything is an object. And the way to think about it is, I'm sure at some point in your life, you all have used Legos or Play-Doh or some sort of toy to build something, right? Or as a kid, you've drawn some stuff and kind of imagined a universe. Well, when we're creating a programming language, if the real world is made up of atoms and electrons and protons, well, when we're creating a programming language, we need our building blocks too. And the pieces of the programming language itself are built out of those building blocks. And so when we talk about an object-oriented programming language, we're talking about a language whose universe is made up of objects, where those are the fundamental building blocks for everything else. In this other object-oriented language called Ruby, everything is an object, including true, false, the number 5, null. Literally everything is an object in Ruby. Most languages are not 1000%. Most languages are a bit of a hybrid. We would talk about Ruby being a pure object-oriented language because literally everything is an object. As we've seen in JavaScript, there are a few things that actually aren't objects, but it's pretty darn object oriented. So I don't want to get too in the weeds on this because it gets into some of the more interesting and also complex things of how JavaScript, the language, works. But everything in JavaScript is an object except for like Booleans. And in fact, let's ask the internet what in JavaScript is not an object, so we can just get a good answer. And maybe this dev site. Here we go. So strings, I guess, aren't objects. So it really is these primitives. A string, a number, a Boolean, null, and undefined are not objects. There are these other objects that start with the capital letter Boolean, number, string that are not types, and these exist and they're objects. And this is a little confusing and not worth going into. Like if I want to, I could do years equals array, and I think it would look something like 2017, 2018, 2019. Let's see if that works. Yeah, so that works just fine. This is using a special kind of object with something called a constructor function to create an array. And JavaScript sort of uses this under the hood, but you literally never will do this. When you're making arrays in JavaScript, you're always doing it like this. So there's some confusion in JavaScript that I don't want to really open the door on right now, but I do want to point out that most things in JavaScript under the hood are objects. That said, it still makes sense to talk about this as an array and treat it as an array. But, to go back to your question earlier, Jack, when we do months.pop, like under the hood, when we create an array in JavaScript, there's an object and it's got a property, and this is a function that does some special stuff to this array. I don't want to dig into that too much right now, but I did want to point that out. I think I'll just pause there for questions because I've been doing an awful lot of talking. And just to see too, is this review for folks? Is this new stuff? Did I get a little too in the weeds there? How are we doing?
It's clicking for me, and I never really touched Java too much, but yeah, I'm tracking. I'm right there with you. You're doing fine for me.
Awesome. I appreciate the feedback. Cool. Where this stuff gets really interesting is combining. Like, let's say I have an array of users, and each element of that array is another array. And it's the user and their favorite food. If I want to look at the favorite food of the second user, I do users and I use my good old bracket notation, and I just bracket notation it again. And this is the same as if I had done, these are two ways of doing the same thing. This way is much more succinct, right? Remember, I said arrays are good for lists of stuff. They're not really good for key value lookups. What actually makes more sense is this. to use the object for this sort of dictionary of users and make a list of our users. And you see arrays of objects all the time in JavaScript. And now all of a sudden, what I can do is console log users one dot food, which would be the same as, and this should be better users, excuse me. Right? This does the same thing here. And this is sort of, we call it like composing, where we start to use these things together. And you will see this all the time. And in fact, maybe what we have here is, upcoming vacations. And this is another list. And it's like France and I don't know, Japan and North Carolina. So I've heard there's really good hiking. Right. And in fact, let me use this format documents. Didn't do what I want, because often what you'll see is this, as this stuff gets longer, you'll see it written out like this, because this is actually a much nicer way to read it. And I need to modify my VS Code settings so that it will do this. And this can be a little confusing if you kind of just see it right off the bat. So I want to just demo it now. And this feels a bit like verbose and a bit much, but once you get used to it, it's actually really nice. And as things get really big, it's actually really nice. Right? So now, if I give us a little more room, the code hasn't changed, but I can kind of see it organized a bit. And you'll see stuff like this all the time when we get to React. And this kind of pattern is incredibly powerful and super useful. The last thing I want to show, I think, with objects is I can modify object properties. Bob food equals pasta, right? If I really want to, I can do Bob bracket food. And this will print out the food. On its own, this doesn't seem useful, but what if, instead of sticking the string in here, I have a variable. And now all of a sudden I can write code to kind of dynamically grab different properties off of an object. And this is a really good pattern as well. And let me just pause and check in and see if folks have any questions, because this is probably a good point to move on. And then we'll talk about pass by value and pass by reference and functions. And then we'll be not quite, but almost at the sort of wrap up point. So I'm curious if folks have any questions. I've been doing a lot of talking, a lot of writing of code. So please let me know. Sometimes I tend to speed up too as I type. So let me know what's on your mind. Cool. So this and this are going to be your best friend. Remember what I said about data being more important than logic? This is data. Think about the shape of your data and the logic will take care of itself. Let's talk about pass by value versus pass by reference. And to do this, I'm going to need to use a bit of drawing with TLDraw. And I'm going to need to do a little setup here. So bear with me. And over here, what this giant box represents is computer memory. And it's not the hard drive. It's going to be RAM, random access memory, which is where the computer puts programs that are running. And when I run my JavaScript code and I create a variable, and let me go ahead and just get rid of some console logs before I dive too deep into this. Forgive me. There's a lot of these. I think that's the last one. Perfect. When I create a variable, and let's say let who equal 5, and I run my code, Node.js, the JavaScript engine, talks to the computer and says, hey, I need you to save in memory the value 5. Right? And then somewhere else in memory, but the JavaScript runtime is keeping track of the variable name and that it points to this value of 5. And let's say I do let bar, and foo and bar come from the term foo bar, which you probably all have heard, and somewhere along the line, programmers just kind of adopted them as fun examples. Equal foo. Now, when I run my code, the JavaScript engine, it creates another variable, it creates another name. Now, does it point like this? Or does it point like this?
I think
And the
it points
answer,
to foo.
It
good
points to
guess.
S
Yeah, the answer is it points to both, depending
Good.
on what we're doing.
because you're not creating
Sometimes,
a deep copy.
yeah, we're not even getting into deep copies. And just to clarify, this is the number 5, which I'll put there a bit bigger. Great answers, by the way, and this is not an obvious issue because, in fact, it behaves differently in different situations. And there's a couple terms here I want to throw out real quick. One term is reference, and the other term is value. And the value is the actual value of a variable. The reference is the variable name, and as we'll talk about in a bit, as someone kind of mentioned earlier, the actual location in memory that the variable lives. Because the way the computer works, computers are extremely organized. The more you learn about them, the more you realize they're really simple and dumb. They just have a million moving parts. Just like different houses on a block have addresses in increasing order, computer memory is organized the same way. And each kind of slot in memory is the same size, and it has addresses in increasing order. And I'm just going to do like A1 for address 1, A2, A3, A4, A5. A couple weeks later, when we talk a bit more about some data structures and algorithm stuff, we'll talk a bit more about computer memory and arrays. But this is a good start. Because when our JavaScript program is running and we create this variable foo and it has this value 5, it's got to go somewhere in memory. And it's got to get stuck there. And then this variable has to know what memory address to go to grab it. Right? And what's happening here is what's called pass by value. And we can test this out really simply, if we console log foo, right now it's going to be 5, right? Now let's change bar to 7. And let's console log foo again. Or actually, let's do it this way. Let's console log bar. Let's change foo, and let's console log bar again. Forgive me. And I'll walk through this once I run it. Right? If bar pointed to foo, when we changed 5 to 7, this would have changed, right? For primitives in JavaScript, they are passed by value. Strings, numbers, null, Boolean, undefined. Arrays and objects are passed by reference. Let's make an array. So let's make this fizz, and we'll make this buzz. This is passed by reference. Right? Over here, we've got our fizz, and it's 1 and 2. And we've got, I'll make these purple. And really, what this points to is the location in memory. And really, in fact, foo and bar don't point to the same thing. What happened was when we created bar, it just made a copy of the value. But let's watch what happens with fizz and buzz. Let's change fizz. And let's see what happens here. I didn't touch buzz. I changed fizz, but the value of buzz changed. Because when we created buzz, because it's not a primitive, it's passed by reference. It points to, I believe what it does is point to the location in memory. I think that's how it works under the hood. And this is true for objects as well. So this is a key concept because we'll see it come into play with functions. And this is confusing because const doesn't really affect this. I don't know, fish. And just every user in here is going to travel to Brazil. So when I run this code, well, it would help if I actually ran the add vacation function on my user. I'm not even returning anything. Plus, this is a const. But what do we think we're going to see printed out here in this console log? Is my user going to have a vacation? I think it didn't like printing it this way. Let's try it this way. Let's see if this works. Let's be really lazy and do it like this. I'm sure there's a better way to do it, but let's see if that does it. There we go. And let me just do the same thing here real quick. Sometimes simplicity is the better path. So don't worry about the buzz stuff, but look at the user. The user got a vacation. Even though this is a const, and this kind of points out the limits of let and const in JavaScript, because if it's a more complex data type, it's not enforcing like true immutability. And so what we have going on over here is, and let me put all the user stuff in red. Let's put the user here, and it looks, like this. Name, David, food. What was their food? Fish. And we had over here my user, right? And so this points, there we go, to the location in memory of my user. And when I call this function, and let's just put, right? I have this here and I do add vacation, my user. What's happening, sorry, my TLDR is going a little nuts. What's happening is add vacation memory address of the object. I realize that this is sucking up the space. There we go. So we'll put this over here. I do apologize about that. Right, what we're passing in here, we're not passing this value. We're passing its address in memory. We're passing its reference. Right, and so this is what we mean by pass by reference. And Python has some behavior like this too. And this is why I did want to touch on this today, because it doesn't come up all the time, but it'll come up about 30% of the time. And it's a really core part of how the language works. And every programming language has to tackle this in one way or another, and most do it in a similar way. And so it's really important as you're writing code to be thinking about, am I passing a value? Am I passing a variable by its value? Or am I passing a reference to the value of that variable in memory? Right? Because it means two different things. When I pass by reference, like over here, passing an object into a function as an argument, I can modify this and it modifies the thing itself. I don't have two objects the same way where with foo and bar and the number 7, we actually have two separate values. I have one object. And I have many references to it. So I realized that was a lot of talking and a lot of jumping around tail draw. So I just want to check in and see if folks have questions, if there might be a good example to go over again, or what's on people's minds.
I think it makes sense. It's like the wheels are slowly starting to turn. It just takes like a little bit of practice and like probably a little bit further reading to truly understand it, at least for me.
Yeah, no, and I appreciate the feedback. And that totally makes sense. Yeah, what else is on people's minds?
Yeah, I'm pretty much there too. Pretty much.
Got it. Yeah. The key thing to remember is there's two ways to pass variables. You can pass by value, which is the simple intuitive way, where I have foo and bar and they're separate and never the twain shall meet. With arrays and objects, we pass by value. So fizz and buzz both point to the same thing. If I modify either one of these, they'll modify this array, right? If I get rid of over here, let's get rid of foo and all this stuff. And let's get rid of that and that. Let's get rid of that. And let's just have another variable here. Right. And the same way, if I did over here, same user equals my user, I'm not creating two objects. I've got two variables that point to the same object. And I think that's the key thing. Pass by reference means we have multiple variables that point to the same object, to the same value in memory. And I kind of lost the array over here, but we had our purple array of like 1 and 2. That's passed by reference, and that's what JavaScript does for arrays and objects. For primitives, it's passed by value. Why don't we take a short break? Why don't we take like 6 minutes? Then we can reconvene at 11:30 and wrap up. We've covered an awful lot of ground. I just want to finish up, I think, talking a little bit about functions, the ternary operator, and loops. Scope, I don't think I'm going to go too into because I feel like our brains have probably covered enough ground with pass by reference and pass by value. But this pass by reference, pass by value stuff, you won't need it immediately, but this is a really core concept. And I remember like the very first programming course I took in college, like we spent a whole day on this, and that's the challenge of a boot camp, like stuff that is covered in a semester, like we cram into a week and you get the highlights of. So don't worry about this kind of being new. The important thing is that this distinction exists and you can kind of continue to learn it and understand it better and see it in practice, right? And that's really the goal that I wanted to accomplish in talking into this, so that you guys are kind of now aware that there's this other piece to programming languages. How does it deal with memory? Are variables pass by reference or pass by value? All right, let's take a short 5-minute break, and I'll see everyone at 11:30. Sound good?
I got a quick question. Sorry.
Yes.
Hold you guys up. So it looks like just kind of researching JavaScript, I can't find, how you have the ID method in Python to get like the memory address. I'm not finding like the equivalent in JavaScript by Googling
Get
around.
memory address of objects. It does appear you may be correct. There may not be. Yeah, there may not be a way to do it. There are some JavaScript language features that like you interact, like you can make a binary array and do things a bit more directly.
Why would I throw you under the bus?
Hold on, someone has a hot mic.
Jack, you're hot mic'd.
Because you didn't have anything.
There we go. Thank you guys. Yeah, it looks like the answer is there's not a way to do it. There's a really nice Stack Overflow post here talking about this. Yeah, what's honestly more useful in terms of exploring and understanding the language is simply experimentation, whether it's in the REPL and observing the same way we could run a scientific experiment, like the same way I wrote a couple lines of code just now, like you can prove to yourself which parts of JavaScript are functioning as pass by value or pass by reference. And I think that's probably the better way to kind of investigate and explore JavaScript in the way that you're saying. Because there's some other things that are really cool about how JavaScript works as a language that we haven't really gotten into yet that add a couple twists and turns. And even in Python, there's honestly like no real value of getting a memory address of something, because the whole point of like sort of high level garbage collected languages like JavaScript and Python is that the runtime does the memory management for us to abstract that away. Like lower level languages like C or Rust are where we maybe have to more directly deal with memory management. With these higher level languages, it's important to understand some fundamentals of memory management, but the whole point of the language is to do that work for us. Let me hop off the screen and pause the recording, and I'll see everyone in a couple minutes. All right, we covered a whole lot of ground there. We spent a lot of time on pass by value and pass by reference. And we do have in the curriculum, if you kind of look on the lesson for today, there is a section here with another set of examples and some diagrams. And it might be useful to look that over. And there's also some example code that we've written as well, if you want to take a look at this, if that's helpful. Though it does some more advanced things here that we haven't really covered. What we're going to talk about now is I'm going to talk a little bit about functions. We're going to talk more about functions after lunch. So today's just, right now it's just going to be a pretty lightweight introduction. I'm going to talk a little bit about scope, because the two big things in programming languages are memory management, pass by value, pass by reference, and scope. All this other stuff is important, but these actually determine so much about the language. Then I will talk a little bit about the ternary operator, which is sort of this if-else thing that's nifty, and a couple gotchas related to truthiness and falsiness, and we'll wrap up with loops. Sound good? Cool. And I've made a new file because that last one was getting pretty darn full. So, functions. Simple question, not quite a trick question, but what is a function?
Is it just like a
Reusable segment of code?
I heard two folks, and I'd love to hear what each of you were saying there.
Coaches.
I was just like, isn't it basically like a small program?
Yeah, I think that's a good way to think of it. A function is sort of like a mini program, or a program is like one big function. And then I think someone else was going to say something as well.
Yeah, I said it was just a reusable section of code that you can customize the parameters for to do whatever job within the actual program that you need to do.
A reusable section of code? Totally. and you can customize the parameters, aka the arguments that you give it. Both of these are true. Functions, we do kind of use them like mini programs, and you can think of like one program as a big function in a lot of ways. And it's a reusable section of code. We use them often for organization. We use them to avoid duplication. To follow this principle, don't repeat yourself. And these are the two big uses of functions, and also something called abstraction, where if I need to like calculate what hour I was born in and I need to use that all over my code, every time I need to do that, I don't need to look at all the logic for that, and I don't want to. I want that abstracted away into the sort of black box that just gives me what I need. Anyone know the mathematical definition of a function? It's not a big deal because this is pretty straightforward. The mathematical definition of a function is and this is not true of programming, but this is where this word and this concept comes from. Some equation where if you give it the exact same inputs, you get the exact same output every time. Right? And if you think of function square a number, and my function returns my number squared or raised to the second power. Sorry about that. And 3 squared is going to give me 9. And every single time I run that function, if I give it the same input, I get the exact same output. Right? And we don't have to write our functions this way, but it pays to think about this in terms of designing functions. Input, have an output, actually return something. Avoid side effects. One function should do one job, which is also called the single responsibility principle. And you'll see it come up in object-oriented programming as well. Like if I have, user equals and in here I do user vacation equals Brazil, and like I console log and I say, Alice is going to Brazil. And let's just pretend this does more stuff. If I do a whole bunch of different things in there, all of a sudden, this actually makes it harder for me to understand my code, harder for me to debug my code, harder for me to modify my code. My function is doing 3 different things, right? Or even worse, what if it didn't return this? What if it just said, and console log, the answer is, now I can run this and it'll work, but man, this is going to be frustrating code to work with. So these are guidelines, They're not hard and fast rules. And sometimes you'll break these rules to use functions to organize your code, to have a reusable section of code. Not every function you write will have to return something, and your functions will inevitably have some side effects. But these ideas will come back later when we learn about React.js. And if you start thinking about functions this way now, it will help you design better programs that are easier to think about. And the more you make each piece simple, the easier it is to combine them into something complex. Right? Simple pieces, simple functions, one thing that does one job, and you can combine these to make really complex code that you can still understand. So let me talk a little bit about the details of JavaScript functions. We already saw this sort of pass by value behavior. We already saw that arguments are in effect optional, that it doesn't matter if we do anything here with y or not. Let me talk a little bit about scope. Let's make a function called can I drink? And let's have it take an age and a country. And if age is greater or equal to 21 and country equals, and I'll talk about what this is in a bit because I didn't cover this yet, but this is saying country equals USA. And now my if statement has two things on the left and right of this logical and. If you want, you can add closing parentheses. It might help you kind of reason about them better. I often will do this when I'm first designing some conditional logic. You don't need them because the order of operations will take care of itself, but it certainly can't hurt. And so this gets evaluated for true or false. And then we do an and it compares it to this. And this gets evaluated for true or false. And otherwise, I'm just going to return false to handle other countries. And let me go ahead and run this. And let's talk about what's going on here. Because there's a couple things. And there's something in particular I did with my if statement. So this part, I think, makes sense to folks. Let's talk about this scenario. Can someone walk me through line by line what happens when I run and execute this code?
Yeah, if you take, so you enter the age, and then the first if statement, it goes into the age. And
Yep.
since it's the and symbol, both conditions have to be true. So because age is smaller than 21, it's immediately false. So it skips the rest of that code through line 36 and goes right to return false on line 30.
Yep. That's a pretty good breakdown, right?
No, actually, there's an equal. It's so it should work, right?
Well, 20 is still less than 21.
Oh,
This
So
is
it has to be
yeah.
bigger than 21 or equal 21.
Yeah,
true.
this is, yeah, sorry, I should have explained that. This is greater than or equal. So if this was 21, it would work, but because it's less than 21, it's not going to work. If I wanted to do less than or equal, it would look like this. And then anyone 21 and under, this statement right here would evaluate to true. Does that help break it down a bit more, Morty?
Yes, yeah.
Awesome. Yeah. And thank you for mentioning that because I totally didn't touch on that. And Chase, thank you for the walkthrough. And like you were saying, I run my code. The JavaScript runtime reads through this function definition. It saves it in memory. It doesn't run anything. It gets to line 43. It says, oh, we need to print. What do I need to print? I need to run this function before I can print anything. Let me look up the function. Let me stick these two values into the first and second argument. And so what it's doing here under the hood is basically let age equal 20 and let country equal USA. Right? That's really, these function arguments mean that under the hood, JavaScript creates variables with those same names inside this function. And those values only exist inside this function. If I do console log, let's just do inside, can I drink? So we can see when we're inside the can I drink function. And let's console log age is age. And over here, let's console log, let me do another age. Right, so I've got two variables named age. But they have different values because they exist in different scopes.
On the
Any
second to last,
variable.
on the line 48, you said ages plus 55 instead of ages the
Oh,
variable.
yeah, let's fix that and hope that this still works. Thank you so much. Yeah, so folks, I make a zillion typos. You've seen me make them. I also, when I'm like writing code for real, run my code like literally every 2 minutes. And that way I find the typos and the bugs when they're small, and I only have to solve one thing at a time. So if I can offer one bit of advice, that would be it. Because raise your hand if you've written code for an hour and then you finally ran it and you had like 10 bugs. Yeah, how much fun is that? So run your code. And this was an advice from a mentor of mine who was like a machine learning engineer guy at Google that I got to work with for a while. I worked for his consulting company and we were pair programming and I got to see him write code. And he was like, yeah, if I don't run my code, like if 10 minutes go by and I haven't run my code, I get nervous. And it's one of the best pieces of advice I ever got because code is in one of three states: good, bad, or I don't know. And when it's in I don't know, that's the worst of all. Because if it's bad and it's just a little error, I can fix it. So please do yourself a favor and run your code all the time. And now that I've gone on that little monologue and fixed that error, I can run it and we see age is 55. And that gets printed out here first, right? Because we don't execute this function until line 50. We define it in line 30, but it's not executed. And so the flow of execution is read this into memory, create this variable, print it out, execute the function, and print that out. And functions have what's called scope. And this is just like memory management and pass by reference and pass by value, a universal programming concept that's incredibly important. Any variable created inside this function only exists inside this function. Let's see if I can scroll up to get it back in there. We'll just clear it and I'll draw it again. And over here, let's go ahead and let's create. There we go. I'll put it down here. Sorry, I'll just draw it when I'm done. Let's create another variable. Even better, let's create it up here. And let's go ahead and let's console log it and see how we do. Now, I might have painted myself into a corner with this, but I think this is going to work okay. So, yeah, a couple. Let's see. Oh no, this is right. I confused myself. So let's walk through what the code is doing because I did just totally confuse myself. And let me go ahead and just draw a line. If I can find the line drawing tool in the Zoom annotator. There we go. So function scope. And the thing about scope is there's something called the global scope. And if we have multiple files, they have different scope, but we can think of this as the scope of our whole program. And so the variables I create inside the function scope just live in here. And in fact, let me add a message here. Oh, man. Global scope. And let's run this again. And I have to scroll up a bit to see it. But we see the first thing that happens. So I'll kind of walk us through this. I run my program. It creates this variable that reads this function into memory. It moves on to line 51. It prints out my var in the global scope. We create the age. We print out the age. The next line below is running the function. I'm not going to scroll down because it'll mess up the drawing. But we execute can I drink. It creates this variable. It prints it out. And we see hi here. So we see here that it's not the global scope, my var, it's the function scope, right? And so scope, it sort of starts from the inside out. And it prioritizes the one in the scope closest to where we're running the code. And this is how we can organize stuff and not have to have every single variable in our whole program have a different name, is because there's scope, right? And I could have made a function inside this function and put another var named my var in there, and it would have given it a different scope. It then does this conditional logic. If we're not of drinking age, it'll return false. And indeed, our age is 20, so it returns false. The function finishes executing. It exits, and let me just clear this so I can scroll down a bit so I can show this. The function returns its return statement when it's done, and then that gets printed to the screen. So this idea of scope is really important and really valuable. And again, like in here, I could do function foo and print that as well. I think we'll see it because when this gets read into memory, I think it gets executed. But if not, I'll go ahead and run it. Yeah, it doesn't. So let's actually execute it. And we can see here, again, same variable name, but it's inside the function scope. So functions in JavaScript create their own scope. And this is really useful. Now, confusingly enough, if I got rid of this inside this foo function, watch what happens. this line here on line 47 right here, my var uses the value from the scope a level up. I have to scroll up a bit to get here. But it uses this value here from the scope a level up.
I have a question about that.
Yeah,
So I thought it was going to return the global myvar, like the buy.
yeah,
So it went into that function, can I drink, and pulled that my variable. Can you explain a little bit how it knows to do that?
yeah. So if I comment out this my var, watch what happens when I run the code now. And I know this is a little harder to see. Here, I'll bump it back up again. What we see is that my var becomes the global scope value. And I wanted to bump this up so I can draw a couple diagrams. So this function has scope. This function, this function has scope. And then we have the global scope of the entire program.
Okay, that makes sense because I thought the foo function was outside the function of can I
Right.
drink. So that
Right.
makes sense. Okay, thanks.
Right. Yeah, totally. And so JavaScript will always look inside the nearest scope and go out. When it's looking for the value of a variable. Some other languages, you would have to actually explicitly pass myvar inside here. We'd get an error. JavaScript does something called a closure that I'll talk about later. But in essence, it kind of bundles it up. So this idea of scope is super important. Most of the time it's intuitive and you won't have to really think about it. But again, just like with pass by reference and pass by value, these are like the fundamental concepts of how programming languages work. So I want to introduce us to those so you know that they're out there, and as time goes on, you can kind of learn more about them and see them more. So I just want to check in and see what questions folks have. Okay, awesome. There are a couple more things I want to show folks. We are almost on the hour. I don't want to rush through stuff too much. I think I'm just going to go ahead and show one or two things real quick. So let me talk about something called a ternary. Let's say we have a function, and can everyone, is this font size good? Can I drink? And it's really simple. If age is greater than 20, and this is the same thing as saying greater than or equal to 21, return true. Else, return false. Right, and now I can't drink if I'm 20. If I'm 21, I can. There is a shorthand for simple if statements called a ternary in JavaScript, and it looks like this. Sorry, it keeps. And let's make, let's say Alice age equals 20. And let me just move the terminal down a bit. So hopefully we can keep this here. So This is what a ternary looks like, and let me actually refer to my notes because it has been a long day, and I want to make sure I don't get this one wrong. And in fact, I was about to. So this is a super short way of writing exactly this same logic. And let me use a comment to show what this does. If age is greater than or equal to 21, return true, else return false. And let me make this lowercase. So what this is condition return if true, else return if false. I'm probably not writing that very well, so I do apologize. It might be easier to maybe write it like this. Like, do I like cats? Actually, I do. But let's say it's false and I don't like cats. So here's the thing that goes inside the if statement that we evaluate that goes to the left of this question mark. If this stuff evaluates to true, return this. If it evaluates to false, return this other stuff after the semicolon. So if this was true, now I do like cats.
I have a question regarding that.
Yeah.
Are you able to, like, if it runs true and false, are you able to run functions in those places of the true?
Yes, you
Okay.
can do anything you want in here. Like this function, and this is where being able to think like a computer is really helpful, right? A function takes inputs and it returns an output. So when we get to line 18, JavaScript says, hey, I have this variable. I need to give it a value. The value is, oh man, it's a ternary. Well, let's evaluate the first part. Shoot, I can't. I need to run this function to get the value. Let me input 22, run the function. It'll return, in this case, true. And then JavaScript says, cool, I can now return this ternary. And the same way you can call a function inside a function. The same way right here, I'm calling a function as an argument that I'm passing into a function. Right? I could have done const is drinking age. Can I drink 21? And put in here is drinking age. Right? This is my argument to this log function. Instead, I'm passing in the return value of this function, whatever this function outputs, as the argument to this function. And we can do the same thing right here with the ternary. And so if I'm of drinking age, I do like cats. But if I'm not of drinking age, I don't like cats.
Okay, thanks. Another question,
Yeah,
sorry.
Great question.
Say you're doing like an if-else statement using the ternary, and if it's true you want to run a function, could you pass in that function where it says Adam likes cats?
Yes, but let's talk about that after lunch because I don't want to talk about passing functions as arguments right now. But in essence, probably yes. Like we could kind of modify that now. I see what you're saying. We could do this. This is kind of silly, but can I drink? Because again, JavaScript will just say, oh, what do I need to return? I need to run this function before I return anything. And let's just, for fun, we can make that 117. Right? And let's make this 117. And we see this true here because that's what this returns. And this is kind of where you can, like, thinking of it, language is useful. Like you can, once you understand the grammar, you can see how you can combine stuff and put stuff anywhere because there's no magic to most of this, though there are a lot of moving parts. Do folks have any other questions about ternaries?
So to be clear, the condition has to be a Boolean, or at least has to reference a Boolean.
Yeah, great question. This is where JavaScript is a little funky. The condition as to JavaScript will basically turn anything into something truthy or falsy. So for example, if I modify this, I'll just, I think, leave it there, uncomment it. What does a string evaluate to, truthy or falsy, if it's not an empty string?
Truthy.
Yeah, exactly. So this is going to evaluate to truthy, to answer your question. And sometimes it's useful to do it this way, but sometimes it's not. And so in theory, you're correct. This needs to end up with a Boolean value, but because JavaScript is very liberal with truth and false, we're talking about truthiness or falsiness. Does that help a bit? And I think someone might be muted. Let me show one thing about true and false, and then we'll break. We didn't get to loops, but I will just show that right after lunch because I don't want to eat too much into our lunchtime. Let me show a gotcha with JavaScript, and this is important. It's also pretty straightforward. How are we doing, by the way? I know it's been a long morning. Like, are our brains mush, or do we have a little bit of fuel in them?
A little more
Okay.
fuel.
A little more fuel. Awesome. And then this is the last one, and we'll wrap. And this one really is short. So let me run this code. Let me comment out that console log. Let's talk about this code. I'm comparing x to 7. I'm saying, does x equal 7? And by the way, the sort of classic logical comparison operators, this is comparing for equality. When you see an exclamation point and an equal sign, it's comparing for not equality. So this would evaluate to false. True does not equal false is true because this is a not. And so similarly, what you'll see is like if I console log exclamation point true, this is false. And if I console log exclamation point false, this is true because the exclamation point flips a Boolean. So what we're doing over here, and I just want to check in to see if folks have questions around this. And I realize I slipped that one in, but we hadn't touched on it. Okay, cool. This is JavaScript weirdness. You won't have to deal with this for a while, but it'll come back later. So X is the string 7. Is this string equal to this number?
It's equal
Apparently.
in everything but type.
Apparently. Well, type is really important because,
This is going
like,
to evaluate to true
yeah,
because
like,
it's not triple equal sign.
yeah, this is where I'm going. Like 7, this is a string. It's not a number, right? And this is a string. It has no numerical value. From the perspective of every single programming language except JavaScript, the fact that this string happens to have the character 7 that happens to be the same character of like the integer 7 is a coincidence that has no meaning from the perspective of that program, right? It's a string. It's not a number. The same way that true is not a Boolean. But when JavaScript was designed, the guy who wrote it decided that double equals will convert, or what's called cast, to change a variable from one type to another. JavaScript tries to be smart. This is bad. I can't tell you how many really difficult to find bugs are because of this. And so JavaScript also has triple equals, which is what's called like strict equality comparison. That does not implicitly or automatically cast the type of a variable and change a variable's type. And you never want to use double equals. I will make sure that when we get to full stack, you guys have some steps to set up some VS Code extensions that will give you red squigglies for this. There's one called ESLint. Nobody uses double equals. The entire JavaScript community has agreed this was a bad idea. You should always use triple equals. And I think similarly for comparisons like this, you also want to use sort of the double equals. So I just wanted to mention that because this is really terrible. Like, this doesn't look too bad, but I can't tell you how many hours of people's lives have been lost chasing down bugs that are due to JavaScript implicitly casting a string into a variable. Because there's other ways that it does this as well. Like, it will do this with true. Like, if I make X true, I think it's going to do it. No, it doesn't, which is actually good. But so I wanted to mention this before the break. And I've gone on a bit, so I think this is a good stopping time, and we should break for lunch. Again, thank you all for being with me. We covered a whole lot of ground. When we come back from lunch, we'll warm up with loops, which will be great, and we'll look at some more advanced JavaScript language features. We'll take a break then, and we'll look at testing. So as I said, today is going to be a big day, and I appreciate your patience. Hopefully this was a useful walkthrough of language features, though. All of these code examples will be pushed to the demos and notes repo. Do folks have any questions before we wrap for lunch?
I'm coming back at 1:30.
Yes, sir. All right, folks, thank you very much.